Hi all, welcome to ChemakhilaM Field the Chemistry. Today we can discuss F19 NMR, P31 NMR, also a small discussion on satellite peak. I already uploaded videos related to spectroscopy. You can watch those from playlist. I will give the link in the description box. And from today's video, that NMR spectroscopy, almost all videos are over, or almost all chapters are over. If I missed something, you can mention those things, and if you have doubt on any of the topic, that also you can mention. And from today's video, I think almost all portion over. Then we have another discussion on this using IR and chemical shift value, that is structural elucidation. How we can find out the structure using chemical shift value and IR value. Those things we can discuss in the next video. Now we can go to the today's video, that is F19 NMR and P31 NMR. And F19 NMR that have an I value of 1/2. We already discussed proton and C13 NMR, or those also have the I value 1/2. And F19 is the naturally occurring isotope and it's of 100% abundance. And the reference used here is trichlorofluoromethane. In proton NMR and C13 NMR, we are using TMS as standard or reference. Here, trichlorofluoromethane used as reference. The range of chemical shift is 0 to 200 ppm. In HNMR, we have taken from 0 to or minus value to some up to 15. Maximum up to 15 was the range, but here the range is 0 to 200 ppm. And when compared to HNMR, that F19 spectra are well separated. That means in HNMR, the peaks are very close to each other, but in the case of F19, they are far apart, or we cannot tell far apart, but the separation is a little more than proton NMR. And in coupling, when coming to the point coupling constant, that fluorine have a wide range. That means it's more than or up to some 5 bond coupling is possible. But in the case of HNMR, we have already told that J3, that means 3 bond coupling is maximum, but there are some other values or some other situations are there, or some in particular some molecules more than J3 is possible, that we have already seen. In one video was there based on coupling constant, in that we mentioned all those things. But generally for proton NMR, J3, that means 3 bond coupling is maximum, but in the case of fluorine it can be up to 5 bonds. Okay, that is another important thing. And the value of geminal coupling is 40 to 370 Hz, and in the case of vicinal coupling, the range will be 0 to 39. That means for geminal the value will be very high, and for vicinal it's less than 30, or sorry, less than 40. And similarly, we already told in the case of proton NMR about cis and trans. In fluorine also, or cis fluorine also, the value is 0 to 58 Hz, and the trans value is very high, that is 1006 to 148 Hz. There is no need to study the values, exact values for F19 NMR. But you have to note down the value of proton NMR. In the case of proton NMR, the J coupling value have some significance because it's very helpful in structural elucidation. But in the case of fluorine, that much not needed. But you have to understand the concept. In cis fluorine or cis compound, the value will be less than 100 or less than 60. And for trans it is more than 100. So when we have two compounds, isomers, cis and trans, that we have to identify, in that case it will be helpful. For cis the value is small, and for trans the value is high. Okay, These are the main points regarding the F19 NMR. That means F19 is the 100% abundant isotope, and the reference, you just note down the reference. It is trichlorofluoromethane. In some textbook it is trifluoroacetic or something like that, I have seen, but that is wrong. Trichlorofluoromethane is the correct reference. Okay, that reference you have to remember, because in maybe MCQ they can ask this question. For proton NMR it is TMS, and C30 NMR also TMS. In the case of F19 it is trichlorofluoromethane, and the range is 0 to 200, and compared to proton, this F19 NMR is well separated, and the coupling constant or the coupling can be up to 5 bond. Then cis have less value and trans have more value. Also vicinal have less value, geminal have high value. Those points you have to remember. Okay. Next is P31 NMR, that also have the I value 1/2, and whatever we have studied up to this, that is proton, C13, F19 and P31, those have I value 1/2. And P31, it's also 100% abundance and have a high gyromagnetic ratio. What is meant by a gyromagnetic ratio? That we have discussed in the earlier video, that is introduction to NMR. Those we have did some problems also. That equation also you have to remember. The relation between frequency and magnetic field. Lot of questions are coming like the from that question. I think in FSL also some one question was the related to frequency and magnetic field. I think, yeah, FSL or set exam also some question paper I have seen. So those equation you have to remember related to that gyromagnetic ratio. Okay, here that P31 isotope is 100% and that have high gyromagnetic ratio, and here reference is 85% phosphoric acid, and also note that it is an external standard. Okay. In P13 NMR, an external standard is used, that is 85% phosphoric acid. So this reference compound you have to remember. Okay, then that much only about P13 NMR. We just want to calculate the number of signals and splitting. Those questions are generally asking how much signal we are getting, and how the splitting, or how many number of lines we are getting, like that question will ask. Now we can have one question that is asked in GATE 2016, and the question is, in the F19 NMR spectrum of ClF3, when measured at minus 60 degrees Celsius, will be observed as a singlet, doublet, triplet, or doublet of doublet. And here also the splitting, it's exactly similar to that proton. Okay, whatever we have studied in proton, that is applicable to all these things, all the NMRs, all the NMR remaining NMRs also the same thing we are using, splitting, number of lines, number of peaks, all those are exactly whatever we have used in proton NMR. Same thing we are using here also, that concept. Okay, now we have a compound of ClF3. First we have to understand the structure of ClF3. For that VSEPR theory is very useful. I think I posted in Facebook and Instagram page also that VSEPR and Shea one table I have given, that you can check, or you can simply refer the first year plus one textbook part 1. In that also VSEPR theory they mention, and the one table is the number of bond pair, number of lone pair. Using that we can determine the structure, also the hybridization. Those things you have to study, because when compound are given, if we don't know the structure, then we cannot answer this thing, because we have to find out the equivalent or non-equivalent atoms, whether it is proton, carbon, F19, P13, whatever, we have to find out the non-equivalent thing. If we don't know the structure, or if you are wrongly writing some other structure, then the answer will be wrong. So here ClF3 have a structure of T shape. Okay, ClF3 have a structure of T shape. and it's derived from trigonal bipyramidal, because Cl have two lone pair and the remaining bond pair when we are representing the structure, we are only considering the bond pairs. So the shape of ClF3 is T shape. So this is the structure, and now we have to find out how many non-equivalent fluorines are there, because we have to find out what F19 NMR. That means we have to find out the non-equivalent fluorines. Here two lone pairs are there. So this fluorine and this fluorine are equivalent, because opposite to this fluorine another fluorine is there. But when considering this fluorine, here two lone pairs are there. So opposite to this fluorine, lone pairs are there, or these two are same type and this is different. So from here, these are A type fluorine and this is B type fluorine. That means we have two signals, that is two type of fluorines are there. That's why we are getting two signals. Now we can check how the splitting coming. Here two signals are there, fluorine A type fluorine and B type fluorine. Now we can see how A type fluorine splits. Here these two A type fluorines are there, that will split due to FB. Okay, so here 2Ni plus 1 times it will split. So here N is 1, because only one B type fluorine is there. 2 into 1 into 1 by 2 plus 1, that is 2. So A type fluorine will split into 2. And in the case of B, there is 2 A type fluorine that can cause the splitting of B type fluorine. So this here also splitting is 2Ni plus 1. Splitting number of lines means 2Ni plus 1. And here 2 A type fluorine is there, so 2 into 1 by 2 plus 1, that is 3. So we are getting two signals, and one will be doublet, other will be triplet. So one doublet and one triplet we are getting. Answer is C. Okay, I think it's clear. Here in ClF3 two types of fluorines are there, A type fluorine and B type fluorine. So it will give two signal. Okay, A type fluorine split due to B type fluorine, and B type fluorine split due to A type fluorine. So A will split into 2 and B will split into 3. 2 means doublet and 3 means triplet. So two signals will be there. One will be doublet, other will be triplet. Next question. In the F19 spectrum of PF5, the number of signals and multiplicity at room temperature are. This question asked in NET December 2011. So first we have to understand, or we should know the structure of PF5, and this is what PF5 structure: trigonal bipyramidal. These three fluorines will be in one plane, and one fluorine above the plane, other will be the other will be in the below the plane. So that is another or in other words, three equatorial fluorines are there and two axial fluorines are there. So we expect two signals, that is one due to axial fluorine, other due to equatorial fluorine. But in at room temperature, these all will be they will show fluxionality. That means axial fluorine can go to equatorial and equatorial will go to axial, like that. Fluxional, it's a fluxional molecule, so we cannot isolate, or we cannot at a time we cannot tell that this fluorine is in equatorial position or in the axial position. So all fluorine will be equivalent and it will give one signal. Okay, so it will give one signal. And the how the splitting will happen. So here all the fluorine is attached to a phosphorus, and phosphorus is, it is an active nuclei with a spin of 1/2. So it will split due to, or the fluorine signal will split due to phosphorus in 2Ni+1 times. So the number of phosphorus we have to consider here 2 into 1 into 1/2 plus 1, that is 2. So one doublet we will get. Okay, so the signal will be 1 because all the fluorines are equivalent, and it will split due to the active nuclei that is P31, and the splitting will be or it can be split into 2, that is doublet. So the answer is the question is number of signal and multiplicity. Number of signal is 1, so we can eliminate C and D, and the multiplicity will be doublet. So answer B is the correct 1, doublet. Okay, next question, find F19 NMR spectrum of PF5. We already did PF5. Okay, there was a condition, that is at room temperature. Here no condition. In earlier case what we told, 3 equatorial fluorines are there, 2 axial fluorines are there. That means 2 types of fluorines are there, one due to equatorial and other due to axial. So 2 signal it will give. So PF5 will give 2 signal if conditions are not mentioned. If it is mentioning that at a room temperature or below room temperature, then we will get a single signal. Okay, here 2 signals are there. So A type fluorine is there, B type fluorine, or equatorial fluorine is there, axial fluorine is there. So how the splitting will happen, or the number of splitting? So A proton will split due to one due to phosphorus, other due to other type of fluorine, so that it is written 2Ni1 plus 1 into 2Ni2 plus 1. One due to phosphorus, other due to another type of fluorine. Here 2 types of fluorines are there, so one fluorine can cause the splitting of other. So first we are considering phosphorus, 2 into 1 into 1 by 2 plus 1, and now we can consider the other, that is B type fluorine. That is number of B type fluorines 2 into 2 into 1 by 2 plus 1, that is overall 6. That is here you can see 2 into 3, that we can tell as doublet of triplet. Okay, doublet of triplet. When we are drawing the structure, you will get the correct idea. This like this. That means equatorial fluorine will give 1 signal, and due to phosphorus it will split into 2, right? Then each one will split further to triplet due to the other protons, other fluorines, that is axial fluorine. Equatorial fluorine will give 1 signal, and it will split into 2 due to phosphorus, and each signal will split into 3 due to axial fluorine. Okay, then we can tell us it is a doublet of triplet. Next, B type fluorine. Here B type 2 B type fluorines are there, and surrounding other fluorine or equatorial fluorine is 3. So first written is related to phosphorus, that is first is splitting due to phosphorus, later due to other type of fluorine. So here 2 into 1 into 1 by 2 plus 1 it's correspond to phosphorus, and this value correspond to A type fluorine, that is 2 into 3 into 1 by 2 plus 1. Okay, this is 2 into 4, that 8 number of lines will be there, that is doublet of quadret. Similarly, we can draw like this, that is axial fluorine is 1 signal, and it will split into 2 due to phosphorus, and each signal will split into 4 due to equatorial fluorine. Okay, this is what doublet of quadret. Okay, this is the answer, and mostly they will ask number of lines. So number of lines will be 6, here number of lines will be 8. When you are getting these values 2 into 3, you check the option doublet or triplet, or triplet of doublet, like that 2 options you can see, you can mark that one. Total number of lines will be 6, here total number of lines will be 8. I think this also clear to you. Okay, if you have any doubt you can ask. Next question, find the P31 spectrum of Me2PCF2Me. First we have to draw the structure. Okay, Me means methyl group we are representing as Me, and this is the structure PME2, that is P connected to CH3 and then CF2 Me. This is the structure, and we have to find out what P31 NMR spectrum, not fluorine. This is P31 NMR spectrum. First we have to consider how many non-equivalent phosphorus are there? Here in this structure only one phosphorus is there, so it will give one signal, right? When we are when asking the question, find out if asking P31, then we have to first check number of types of P present. If you are asking for fluorine NMR, then you have to check how many different types of fluorines are there. Okay, later only you consider splitting. Here you can see that only one phosphorus is there in the entire unit, so it will give only one signal. Now we can consider the splitting. Okay, now we have to find out how many different types of active nuclei are there that can cause the splitting. Here carbon is there. Carbon is an active nuclei, but in C13 NMR it is already mentioned that the abundance is very low, so it won't cause any splitting. Okay, then next to carbon, what hydrogens are there, and that is an active nuclei, so that can cause splitting. And here also you can when we are considering the hydrogen, it is connected to carbon, then it is connected to phosphorus. That means two bond coupling, so that is possible, right? Next, fluorine also an active nucleus, so that can also cause splitting. But when we are considering this CH3, with this fluorine you can check hydrogen connected to carbon, carbon connected to carbon, then connected to phosphorus. So the extent of coupling is less. So this CH3 or the proton present in this CH3 is not able to split. So only two types of splitting happen, one due to this fluorine and other due to these hydrogens. Okay. Then first we can consider the hydrogen splitting. That is there are overall 6 hydrogens are there, 2 into 6 into 1 by 2 plus 1, that is 7 septet. So that 6 hydrogen cause splitting. Another one is due to 2 fluorine, that is 2 into 2 into 1 by 2 plus 1, that is a triplet. So overall this you can multiply these two, right? Then overall 21 lines will be there in this spectrum. One signal split into 21. It's split into septet due to hydrogen, and that can further split into triplet due to fluorine. Okay, so this is what P13 NMR of this compound. Next question, find out the number of lines in P31 NMR of NH2 twice PHF3. This asked in December 2012. First we have to draw the structure, and it is mentioned here N15. Okay, what the peculiarity of N15? That we can check. Okay, here question is what P31 NMR. So here also phosphorus connected to hydrogen, so this hydrogen can cause splitting. Okay, first we have to consider how many signals. Only one signal, because only one type of phosphorus is there, so only one signal is there. So phosphorus is connected to hydrogen, so this can cause splitting. And phosphorus is connected to fluorine, that can also cause splitting. And it is connected to nitrogen, that can also cause splitting, because nitrogen also an active nuclei. And here another type of hydrogens are there, that can also cause splitting. That is overall 1, 2, 3, 4 types of splitting are there due to this A type hydrogen, B type hydrogen, nitrogen and fluorine. Okay, now we can write as it is one signal and splitting due to 2 fluorine, 1 hydrogen, 2 nitrogen and 4 hydrogens. And it is 2Ni plus 2Ni 1 plus 1, and 4 times we have to do that and multiply. Okay, first we have to consider fluorine. 2 fluorines are there, 2 into 2 into 1 by 2 plus 1, and next is due to hydrogen, 2 into 1 into 1 by 2 plus 1, and this is due to this hydrogen. Okay, next is 2 nitrogen, 2 into 2 into 1 by 2 plus 1, and here you may have a doubt. Nitrogen have a value of I equal to 1, but that is one we have to understand. N14 is having an I value 1, N15 have a I value of 1/2. That always remember. Most of the people can maybe they will make a mistake here that they will write 1. N14 is 1, N15 is 1/2. So here it's mentioned that N15, so the value is 1/2. Okay, 2 into 2 into 1/2 plus 1, and later due to 4 hydrogens, 2 into 4 into 1/2 plus 1. Then overall we will get 90. So option D is the correct answer. Okay, first we have to find out the number of signals, later the splitting you have to consider. If you are get confused or suddenly writing the splitting, that will be sometimes getting wrong. First you have to find out the number of signals, later you consider splitting. Then it will be very easy for you to calculate the value. Okay, and remember N14 is N14 have an I value of 1, and 15 have an I value of 1/2. That always remember. Okay. And last question in this video, the correct appearance of F19 NMR of WF6 tungsten fluoride molecule, and consider W183 is have an I value of 1/2, and it is 40% of natural appearance. Okay. Then the signal will be singlet, doublet, singlet with 14% doublet satellite, and doublet with 14% singlet satellite. And this is what here we can discuss about that satellite peak. Now our example or the molecule is tungsten fluoride, and here you can see that it's a 6 coordinate complex. That means it's an octahedral complex, and all fluorines are same, and it will give one signal, that is a singlet, or one signal you will get, right? It will give one signal. Now here they mentioned that 14% natural abundance for this type of this isotope. So when there is if they are mentioning the natural abundance, we have to consider, or we have to do the problem like this. Okay, here 14% abundance that have an I value of 1/2. So remaining percentage, that is 86% have the I value of 0, right? 86% have the I value 0, and 14% have the I value 1/2. Okay, this is clear, right? 86% have I value 0, and 14% have I value 1/2. Then if have an I value 0, then it will give a singlet. If have an I value of 1/2, it will give a doublet, right? 2 into 1 into 1/2 plus 1, that is doublet. Here only the one tungsten is the, so the value here we have to write 1. So this can give a singlet and a doublet. How we can write this? Right, like this we can write, because this doublet means overall 14%, so doublet means it divided by 2, that is 7%, 7%. So this is 86% singlet, and a doublet of 7%, like that. Like this we have to represent. Or another representation is like this. So here one big peak is there, and some shoulder peak is there. So this shoulder peak is known as satellite peak. So how we are telling that this singlet have a satellite peak of doublet. A doublet satellite peak is there. So here we can tell that this is what singlet, and these are doublet. So the satellite peaks are doublet, and it's the satellite peak of a singlet. Okay, like that we are mentioning, like it is the these are the satellite peaks of a singlet. Okay, so the correct answer will be singlet with a 14% doublet satellite, right? And this 86% it is a singlet, and there is a 14% doublet satellite, and that we are split into 2, like 7% and 7%. So the answer is singlet with a 14% doublet satellite. This question is very important, and recently this kind of questions are asking in CSIR. So that you can expect in HSST exam or assistant professor exam. Or what is mean by satellite? If it is a description mode of exam, then it will be they will ask it is a what is mean by satellite peak in assistant professor exams or any other exams. But I think it is a MCQ exam itself for higher secondary. There is it's not mentioned that it is descriptive or MCQ type, but you have to understand what is meant by satellite peak and how we are expressing satellite peak. Like it says satellite doublet satellite peak of a singlet. A singlet have a satellite peak of a doublet. Like that also we can tell. Okay, and this is what about F19 and P31 NMR and satellite peak. These kind of question or the satellite peak questions are coming when the abundance is mentioned. Okay, or some percentage it's mentioned that this kind, or in question it's given that some percentage natural abundance have this much high value. Rest we have to consider as a inactive nuclei, and those will give singlet, and other according to that value doublet, triplet, or whatever it will come, that we have to write. And this value that we have to split accordingly. Now here it is a doublet, so we are splitting into 7%. Okay, so this is a singlet peak and with a doublet satellite peak. Fine. If you have any doubt on this video, you can mention. If you like this video, like, share and subscribe ChemakhilaM, and you can follow me on Instagram, Facebook, and you can direct mail me. Don't forget to press the bell button, then only you will get a notification when I am uploading videos. And now NMR almost all topics are finished. Next video we can do some structural elucidation. Later we can do some I think ESR is pending, ESR UV, then mass, and okay, that much is there. And photon electron spectroscopy also there, that also we can do one video. And then almost spectroscopy is over. If you have any doubt you can ask, and if I missed any topics, that also you can mention. Okay, thank you for watching.